All right, so we're going to look at another example where exponential growth and decay can apply, and that is something called compound interest. So most of you guys know that when you put money into the bank, the money just doesn't sit there. They invest it, and hopefully it grows over time, okay? And the way you could figure out how much money you're going to accumulate over time could be by using this formula for something called compound interest. So once again, it looks pretty similar to that exponential growth equation, but there's just a few extra pieces we have to consider. Okay, different letters, different variables, but they basically mean the same thing. Okay, so A is what you're trying to solve for usually. It's like the current amount. Okay, after a certain amount of time, how much money do you now have in your account? P is what we call the principal amount. Okay, just different letter for the same meaning. P is what you originally put into your bank account. Inside your parentheses, you're always going to have a 1. It's always going to be plus because your amount should grow. And then R still represents your rate. This is usually written as a percentage. Still the same rule, convert to decimal. And then the extra piece here that we're going to have is N. So N is the number of times the interest is compounded each year. Okay, a little bit weird, but we'll look at some examples and then figure out, okay, how do you figure out what N is equal to? And then T still represent the same thing. T is time in years. Okay, so it says determine the amount of investment if $300 is invested at an interest rate of 3.5% compounded monthly for 22 years. Okay, so this is a compound interest question, pretty clearly, based on what they're saying. So you know you're going to use the formula. A is equal to P times 1 plus R over N raised to the NT power. Okay, so our job here is we got to figure out what P, R, and N are all equal to write the equation. Okay, so I'm still going to have A is equal to. P represents your principal amount or initial amount. What was the initial amount you invested into the bank? And it says right here that you start off by with a $300 investment. P is going to be equal to 300. Okay, I'm always going to have a 1. I'm always going to have a plus. R still represents your rate. The rate they're telling you was 3.5%. You cannot plug in 3.5 for R. You have to convert this to a decimal. You have to write it as 2 decimal places to the left, 0.035. Okay, I'll plug in 0.035 for R, pretty small number. And then here's the new one. N is the number of times the interest is compounded each year. Okay, so what you see here is that the interest is compounded monthly. It's compounded every month. And N represents the number of times the interest is compounded each year. So if it's compounded every month, here's a question you ask yourself. How many times in the year will the interest be compounded? Well, if there's 12 months in the year, it means that the interest is going to be compounded 12 times that year. So in this case, N should be equal to 12. This is all going to be over the number 12. Then it's raised to the NT power. Okay, this number down here should always be the exact same as this number up here. So it should be 12 times t, and we want this to represent for any amount of time, so we'll just leave that variable as t right now. Okay, so when you clean this up a little bit, my equation that'll help solve for any amount of years should be 300 times, and this, I'm going to clean up this fraction a little bit, 0.035 divided by 12 comes out super nasty, but when you add 1 to it, it should be something like 1.002917. Okay, try not to round that thing until the very end, but raise the 12t power. Okay, so this is my equation for any amount of time, but in this question, they're asking specifically for 22 years. So all we have to do here is use this equation, but in for t, I'm going to plug in 22. So I'll have 300 times 1.002917 raised to the 12 times 22 power. Okay, so order of operations here. Let's clean this up a little bit. the first thing I'm going to do here is I'm going to multiply these exponents together. 12 times 22. I'll have 300 still. So the 1.002917. And then 12 times 22 should give you something like 264. Okay, I know the numbers are ugly, but the process is still the same. Use that graphing calculator. Use your order of operations. The next thing you have to do is you have to take this number and raise it to the 264th power. Once again, it should become really nasty. A is equal to, still going to have a 300. And then once you take this number and raise it to 264th, I got something like 2.15753638. Try not to round that thing like I said. We want to keep it as precise as possible. But then the final step is that you just take 300 and multiply it by that ugly number. And you should get something like $647.26. Okay, so what that means is with this plan, at a 3.5 interest rate, compounded monthly for 22 years, if you just put that $300 in and don't touch it for 22 years, you should end up with $647 in the bank. Okay, so this example was compounded monthly, but there's different words we could throw at you, and here's what you need to know. So if I say the word annually, okay, that just means once per year. Annually means once per year. If you see the word annually, n is going to be equal to 1. If you see the word semi-annually, semi-annually means twice per year. N would be equal to 2. If you see the word quarterly, how many quarters in a dollar? There's 4 quarters in a dollar. That means 4 quarters per year. If you see the word quarterly, n is equal to 4. And the last two examples you might see, compounded weekly. Does anyone know how many weeks are in a year? The answer is 52 weeks per year. If you see the word it's compounded weekly, you should plug in n is equal to 52. And then the last example you might see, compounded daily, that'd be quite a bit. There are 365 days per year. N would be equal to 365. Okay, so based on the word you see in the word problem, this will help you solve for